Remember, we did have quadratic equation. Now we have the quadratic. In this chapter, we get some very nice result, very good one. We start with this quadratic function, then we go to the polynomials and the rational functions. They are very, very useful and easy chapter. Okay, so that is 3.1. Let's see what is quadratic. Okay, quadratic functions, not equation, functions. I give you all the properties first, and then we go to the problems. So, you know, the quadratic function is a function that's expressed by a quadratic expression. This is it, a function. Function f of the following form. Okay, following form. The form would be f of x equal to ax squared plus bx plus c. This quadratic expression, these are all numbers, can be 0 but not a, okay, where a, b, and c are numbers with, of course, a cannot be 0. Because if a happened to be 0, you know that it's not going to be quadratic. It's going to be called, okay, it's called a quadratic function. Very classic result in algebra. Okay, so this is going to be a quadratic function. Okay, example is going to be, for example, you know, if you're given f of x equal to the 3x squared minus x plus 5, this is a quadratic function. Is a quadratic, okay, quadratic function. We need those a and the b, with a equal to 3 and the b equal to the negative 1, if you like, and c is 5. Okay, this is going to be a function. So this is going to be a function. So what we are going to be interested in, we're interested in domain of the function, graph of the function, range of the function. Okay, this is what we are going to be interested in. Generally, this is a polynomial. You know that is a combination of powers of x. So what's the domain of this function? Any suggestion? If it's a polynomial, so what's the domain of this function? Any suggestion?
All real numbers.
Excellent, all real numbers. You see, there is no fraction, no radicals, no division. That's it. So it's all real numbers. So the domain is all real numbers. We need to find the range, then we are going to get into it. Okay, so it's a quadratic function, but at the same time, it's a polynomial of a second degree. Okay, so let's list the properties first. Okay, then we are going to give you problems. Okay, what is properties? Properties of this quadratic function. I'm going to call it f of x equal to ax squared plus bx plus c. Okay, the first property is the domain. We talk about it, so we know that the domain is R. F is a polynomial. Okay, it's going to be a polynomial function. So the domain is all real numbers. Okay, for the range, we wait. That is going to be the domain. Second one, the graph of this function. The graph is a very popular one. The graph is a parabola. Okay, so the second part, the graph of this function. Okay, this is it, the graph of the function f. Of the function f is going to be called, you know that it's called a parabola. Okay, it's going to be a parabola. So the graph of the parabola, it can be open upward. Okay, that's one, or it can be open downwards. Okay, it's going to be open up if A is positive, and it's going to be open down if A is negative. Okay, so the graph, okay, the graph opens up, upward, if A is positive, and downward, okay, downward if A is going to be negative. So it's very easy, okay, it opens and downward. Okay, so it's very easy to identify it. That's a different way to define it, and we're going to do it, but for the time being, this is going to be the case. Now, this graph would have a lowest point or a peak point. This lowest point or the peak point is going to be called the vertex. Okay, so the lowest point of the graph, okay, this is it. So the lowest or the highest point, okay, on the graph is going to be, is called the vertex. Okay, vertex of the graph of the parabola. Okay, that is going to be a vertex, and we are going to denote it by V, and we give you the coordinate, and then there are different ways to give you the coordinate, but I'll give you this one quickly. Okay, are you done? So the lowest point or the highest point is going to be called a vertex. It's going to be denoted by, okay, it is denoted by V, where the coordinate of the V is equal to negative B over 2A. We're going to show you later why. This is the X coordinate, and the Y coordinate is F of negative B over 2A. So we get this number first, we drop it into the function. Okay, so basically these two numbers are important. X equal to the negative B over 2A. Okay, and the Y coordinate is F of negative B over 2A. Okay, so this is going to be the vertex with the coordinate that we talk about it. Okay, now there is a mirror. You see the vertical line passing through the vertex would divide the graph into two parts, two equal parts, 50% to the right, 50% to the left. This graph is going to be called, okay, axis of symmetry. Okay, so graph is symmetric, and that would be very useful when we want to graph it. Okay, so the vertical line through the vertex, the vertex. Okay, it's graph, divide the graph into two parts. I'm going to call it, okay, the vertical line through the vertex is called, okay, it's going to be called the axis of symmetry. The graph is going to be symmetric with the equation. Okay, with the equation is a vertical line. It starts with the x, so x of this line is the same as the x coordinate of the vertex, negative b over 2a. Okay, I'm going to call it axis of symmetry. Okay, this is going to be the one in short. So this is it. if this is going to be the parabola, and so the axis of symmetry is the mirror. Okay, this is going to be a mirror, so the equation of this line is x negative b over 2a, or the other way around, it doesn't matter. Okay, it can be the other way around, and it is going to be the same thing, mirror here. Okay, so x equal to negative b over 2a. Okay, so we got the vertex and we got the axis of symmetry. If you want to do anything to this function, if you want to solve any problems of this section, you have to find the vertex first. It's a 60% of your points in these problems. Then you can decide what you want to do about it. Okay, so vertex, axis of symmetry, negative b over 2a, and we drop it into the function f of negative b over 2a. Okay, so what is going to be the other things that we have to know? That's the vertex, the information that we have. Number 3, okay, when the graph is opened apart, we get the minimum. The lowest point would give you the minimum, the highest point, okay, the peak point will give you the maximum. So we'll be able to find, okay, the maximum and the minimum value of the function. When you talk about the maximum and the minimum, this is the value of the y. So that value would comes from the vertex again. You see the y coordinate of the vertex. Okay, there you are. If this is where we are going to identify the range. If a is positive, the graph would be curving up, so we get the minimum. Okay, if it's going to be the case, f has a mean. F has a minimum value. Minimum value at the vertex, okay, at v. And the minimum value of f of x is just the y coordinate of the vertex, f of negative b over 2a. That's the minimum. Okay, when you have a minimum value of a function, then you'll be able to find the range of the function. Okay, how far your function go up and down. In this case, okay, the range of the function. Range of f is equal to, any suggestion, if the minimum is 5, what is the range of the function? Minimum is the bottom value of the function. So if the minimum is 5, what's going to be the range of the function? Any suggestion? Minimum 5. If it's going to be no, where is the infinity? You see the bottom is 5. You see the bottom is 5. 5 up. 5 up, you know the up is going to be positive infinity. So in this case, you see the range of the function is the minimum closed interval of f of negative b over 2a and up a positive infinity. That's the minimum. If the minimum value is 5, the value of the function is 5 up. 5 up forever. So 5 and positive infinity. Okay, because this is the bottom. The bottom on the y-axis. Okay, any question? So that's crucial part of the problem. Application problem is coming from here. Positive means open up. We have a minimum. Where is the minimum? Y coordinate of the vertex. F of negative b over 2. So that's a minimum. So the range of the function is going to be minimum up. So that's for the minimum. Okay. If a is negative, it's the other way around. So number 4. Number 4, if a is negative. Negative means down. It's going to be downward. So we get a maximum. Okay. F has a maximum value. Maximum. value at the vertex again, at V. And same thing, same number, the y coordinate. Okay, the maximum value of f of x is going to be what? It's going to be f of negative b over 2a. Now the range. This is the top value of the function, the peak. Okay, so it's going to be from the bottom up to peak value. So in this case, the range, so the range of f is, you got the up, you see the peak point. So this is going to be up. So you start from negative infinity up. That would be the range. Okay, when you have the maximum, you go from the bottom to the maximum, which take you to the, from negative infinity. If you have a minimum, you start with the minimum and you go to the top. And that's it. That's all we need to be able to solve any problems. In this case, there is another interpretation, or just looking into this type of functions. I'm going to give you one problem first. This is one, we call it classic. There is another format, we call it the standard. Then I explain that one too. Okay, this is the opposite to the interpretation of your book, but we do both of them. Okay, any question? So make sure you need the coordinate of the vertex really, because that's works for you. So you find that coordinate and then you wait to see what they are asking you. Okay, so officially 2 problems only, and we give you both of them, or 2 or 3 for the quiz. Okay, so example, this is very standard one. We usually ask you to this seed. We would like you to identify or identify the vertex, coordinate of the vertex, and the axis of symmetry. The axis of symmetry. Okay, of this quadratic function f of x equal to the x squared, let's say minus 4x plus 3. Okay, and sketch its graph. And sketch, okay, the graph or its graph. That's it. That would be enough, we can give us all the other information free. So this is the way we do it with this method that we talk about it. You identify the a and the b correctly. A is the coefficient of the x squared, and the b is the coefficient of the x. We don't need the c. We go for the x coordinate of the vertex. X coordinate of the vertex. X equal to negative b over 2a. That's x coordinate. Substitute. It's a negative b is a negative 4, 2a, 2 times 1. We multiply the bottom one first. So that gives you 2. The signs, we have 2 negatives. 2 negative make it into the positive. 4 over 2 is 2. So that's the x coordinate of the vertex. Any question? You drop it into the function, you get the y coordinate. Okay, so we continue. So drop it into the function f of 2. F of 2 would be 2 squared minus 4 times 2 plus 3. 2 squared would be 4. So that's a 4 minus 8 plus 3, which is a negative 1. Okay, that gives you 2. 2 squared would be 4, and that's 8. So f of 2 equal to negative 1. You know that the vertex is x coordinate 2, y coordinate negative 1. 2 and negative 1. Axis of symmetry, x equal to 2. That gives you axis of symmetry. Any question? So that's the main part. You want to graph it? We can graph it right away. For the graph, we are going to preview it first. What type of graph do we have? Okay, A is 1. is positive. Positive means up. So this is your graph. That will help you. Now we're going to graph it. Okay, how are going to graph it? This is it. Locate the vertex, 2, -1, 2, -1. This is the vertex. Bring the mirror. The mirror, the vertical line. Axis of symmetry. You know that the graph would be, this is the vertex, it's going to be curving up. We need help. There are different ways to do it. You can find the intercepts, but we suggest symmetric property. Remember, this is symmetric 50% to the right, 50% to the left. You need one more point to graph one portion of this. You can pick one point. The easiest point is the origin, 0, 0. So what I do is I get help. You can pick any point you like, but I get help from 0, 0, x equal to the 0. If you put x equal to the 0 into the function, you see, that gives you 3 here. So that gives you 0 and 3. Located 0, 3, 1, 2, 3. You see, this is 2 points out. One of them is the vertex, it's going to be the other one. Connect, just a sketch graph. This is going to be one portion of the graph. But it is symmetric. This is the mirror. Get the mirror image. The mirror image equal distance, and this is going to be the graph. Nice and easy, okay? So we like to use it, right? There are some other methods I tell you later, but this is the quickest way to do it, and we just took care of it right away, and then we are done. Okay, so the vertex was 2 and -1, so this is a -1 here. Okay, -1, -1 up over here. Any question? You may ask some extra question, which is free here. We have a minimum. What's the minimum value of the function? The minimum, you see, the minimum value of your function is a -1, which is the y-coordinate of the vertex. Okay, we get the minimum. Remember, this number can be a maximum, or can value of the function going up and down. You see the y value up and down. This is the value of the function. Going to the right to the left is the value of x. So you are going to have a minimum. What's the range of the function? The range? Any suggestion? The range is the value of the function, the y-axis. Okay, the y-axis. So as you can see, you start with the -1, which is your minimum. You go up, 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 up. So these are the bonus, if you like. So the minimum value of the function, you see the value of the function going up and down. So the minimum value is a -1. You see on the y-axis, you start from here and you're going up. So the minimum value is a -1. So the range of your function, the range is how far y go up and down. So the range of the function starts with a negative and going to positive infinity. This is open, but this is always closed because you already got the minimum. You see, these are going to be the bonus that you are going to easily have. Yes, you're right. Okay, any question? So this is complete description. You don't need these two for this problem, but they may ask you. So it's the same problem. It's the same problem. Get to know it. You see, the value of the function is on the y-axis. Remember, x is the input, y is the output. So this is y. So your y starts from the -1. There is nothing here. You see, there is no function here. So you start with the -1 and everything is up there. So the range of the function starts from -1 to go to the positive infinity. So that's all we need to know. Any question? So that's case 1, or the way they express it really. It's going to be case 1. So preview the curve first and then just do it. And there are a couple of practice one. We're going to do it in a minute. Any question? So that's one version. The other version is the same question, but they may ask you indirectly, you see. Look at this one. It's a kind of calculus format, function format. So the next problem is going to be, we may give you the function, you see. May give you the function, say suppose, okay, suppose your function is f of x equal to, okay, f of x is equal to, give you something like, how about x squared minus 3x plus 1 this time. Let's call this one negative. Is a negative x squared minus 3x plus 1. This is your function. You may be asked, find, okay, find the domain. Find the domain and the range of the function. The range of the function. It's the same thing. You have to find out whether this function would have a maximum or a minimum. Okay, that's it. It's going to be the case. Okay, let's see how we're going to find. The domain is clear. Domain is all real numbers. It's a polynomial. Okay, so solution. We are done with the domain. You see, the domain is going to be R. You have to write it down. Remember, you got points from the domain on the test. That's going to be the domain. For the range, you have work to do. You know that. You have to find out what type of function do you have. Do you have a maximum? Do you have a minimum? So what's going to be the maximum and the minimum? You know that the max and the mean would be happen at the vertex. Okay? So we can preview it to see what you have. You see, your A is what? A is a -1 and your B is a -3. Okay, so if you want to preview it, -1 is negative. Negative means done. So we have a maximum. Okay, it's going to be a maximum. And so you need to find the maximum value of your function. The max, remember, is the y coordinate of the vertex, f of -b over 2a. So if you find this number, that would be the top value, the maximum. Then you can write the range. Okay, so you want to find the range. The range would happen at the minimum or the maximum. Okay, so which one is it? You identify it. Now you go and find it. Okay, any question? So you have to confirm it, remember. Okay, there you are, just the same operation that we did before. A is a -1, B is equal to -3. You have to find the x first. X coordinate is -b over 2a. So you substitute, it's going to be negative. Your b is a -3. 2a, 2 times a -1. And do the operations, the bottom one first. It's going to be negative. We have a -3 on the top. It's a -2 over here. You have 3 negatives, you see? 1, 2, 3. 3 negative would be negative. So that's going to be -3/2. So that's your x coordinates. Any question? You drop it into the function to get your maximum. Okay, so what's going to be f of -3/2? Okay, -3/2 into the function. This is the function. Substitute, use parentheses, okay, not to miss it. So it's a -x squared would be minus, okay, -3/2 squared, 3/2 squared, minus 3x minus 3 times -3/2. Okay, this is going to be the case. And what? And a plus 1. Okay, this is going to be the case. Now we have to simplify it. Okay, you keep that negative outside. The negative inside will disappear. You see 3 squared would be 9. 2 squared would be 4. Okay, now negative positive. So that gives you 9/2 plus 1. Okay, 9/2 plus 1. You know, a little bit of common denominator. So -3/2 positive would be 9 quarter. There is a negative one side. Okay, negative positive. So this is it. So what we are going to do is We find the common denominator, it's going to be 9/4, and this is going to be 18, and this is going to be 4. Okay, so that would give us the answer to get these numbers. Okay, so this is going to be the case. So what I have is going to be a positive 9, 13, 4. So f of negative 3/2 is going to be equal to, okay, is equal to the 13/4. So this would be what? The maximum. So the maximum value of the function is going to be 13/4. This is the largest value of your function, 13/4. So what's the range of the function? Any suggestion? Range? You have the maximum value of the function. So what's the range in interval notation? Any suggestion? Start with the, you see the maximum, when you have the maximum is here, you see? This is the maximum. So you start from negative infinity. You see, you have the maximum, you have the value to the right. If you have the minimum, it's the other way around. Okay, the maximum is, this is the most. So the most you can go up is 30/4, if you like. Okay, so the maximum, the range is going to be negative infinity and 30/. Any question? So you have to focus on the vertex to get these, okay, maximum and the minimum. All the problems would be related to this one. We do this one in calculus, but we have another method. But this one is very, very easy to do. Okay, any question? So as you can see, the important part is the vertex. Now, remember the equation of a circle? The equation of a circle, we use completing the square method, and we write it down in the format of what? X minus h squared plus y minus k squared equal to the r squared. We can do the same thing to the parabola or the quadratic function. So that gives you another format. That format is easy to handle if you like completing the square, or otherwise that would be given to you. So you should be aware of that, okay? So I give you a remark for that one. And from time to time, you may see problem given to you in just two different formats. This format is much, much easier. Okay, so I give a remark. So you must know both of them. So that is going to be the case. So this is it. One can apply, or I can apply. One can apply. Remember, completing the square method. Completing the square method, okay, to rewrite, if you like, to convert, if you like, to convert the quadratic function, the quadratic function f of x equal to ax squared plus bx plus c. You can, you have to divide by a and do the completing square. Okay, to convert the quadratic function f of x into the following form. What is that form? Very easy form. Would be y equal to, or f of x. You have to factor out the a is going to be x. We call this one h squared plus k. Okay, if the coefficient of x squared is 1, it can be nicely done. And sometimes it's easy to know. Okay, we can write it down in this format. When you write it in this format, you are going to have, you see, where v equal to h comma k is a vertex, is the vertex. Remember, for all these problems, you need the vertex. So if you have the vertex in this form, done. Okay, we got the vertex. Remember, x equal to the h is going to be axis of symmetry. You have the maximum, minimum. So everything can be done nicely. So that's a very good method. So if this is given to, so it's going to be the vertex, and if you like, and x equal to the h is the axis of, okay, axis of symmetry. So in your book, you have both formats of these problems. So it's nice to know it. And so if this form would be given to you, you're lucky because you don't need to do anything. And you can see, give you one example. And if you are good in completing the square, you can stay with this method forever. Okay, but you got to be patient with this a is not equal to 1. Okay, but my suggestion is you just know both of them because we give you one from each type. Okay, so this type is ready. So for example, you see this one? And suppose you want to sketch the graph. Sketch the graph of, look at this one, y equal to, what? Equal to -3 times x plus 2 all squared minus 5. You see, now you realize this is quadratic, okay, quadratic function. So you don't have, some people, they simplify it. They go to that method. No, it's ready. It's ready. You see, just compare it, solution. You see, this is going to be the case. A is a -3. H, opposite side, is a -2. K is the same one. So the vertex is -2 and -5. That's it. Vertex. Mirror, x equal to -2, x of symmetry. Okay, we compare it. This is A, remember, A times x minus h, opposite sign. It's like x plus 2 equal to the 0, that give you x equal to -2. But the k is the exact one. Okay, and that's it. This is the vertex, axis of symmetry. You want to graph? Preview the graph first. You see, A is negative. Negative means done. Done. So this is your graph. So how are we going to graph it? Graph the vertex first. Vertex, -2, -5. -2, 1, 2. -5, 1, 2, 3, 4, 5. So this is the vertex. Okay, so the graph is going to be curving down. I need help.
What did you say AOS was?
Axis of symmetry, the mirror.
Okay. Thank you.
Okay, so we need help. Help. We need a point. 0, 0 is the best one. Put x equal to the 0 here. Okay, it takes a little bit more time to find it. It's going to be -3 times 2 squared minus 5. It's a big number. It's going to be 4, 12, -17. I have no place to write it down. Okay, so I put it here. You see, this is the vertex, okay, and this is the axis of symmetry. So you know, I got these points. I'm sorry, I have to go to the next page. I hate to write down here. Okay, so it's going to be this is it. We get, I'm going to put it here. So this is what we have. We have a -2 and -5. See, that was a -2, -5. Suppose this is a -5. Okay, so that was the mirror. That is the mirror. This is the vertex. So we have a -17. Okay, this is somewhere -17. Okay, you get this line first and use symmetry to get the other one. Okay, so this is going to be much easier to get these numbers. Okay, again, you see the maximum value. The maximum value is, you see the maximum value is -5. What's the range of this function? The range, you have the maximum. Range, any suggestion?
Negative infinity to infinity.
Not the infinity. You have the maximum.
-5.
See, that's going to be 1. Okay, so this is the way we are going to operate. So this is much easier, of course. And you can use those other, those transformation of the graph that we talk about it, but it's not going to be a big deal to get all these, together. So 2 different methods that would be useful, and this is what we have. Okay, any question? There are a kind of a nice application, but because of your quiz, we won't get time. So let's go over that practice quiz first, and then we may talk about the application when we get to the test. Yes.
Quick question. So for the graphing, are we gonna have to like plot a certain amount of numbers on there or points on there, or is it just like 2, like you did right there?
Yeah, I mean that's it. You get the vertex. Okay, vertex and 1 hill. You get the direction. That would be enough. Okay, that's it. Because we sketch the graph, it's not going to be. But the part that we are interested in must be clearly identified. This graph is curving down, and the maximum is -5. Okay, identify these points, and that would be enough. Okay, that's it. Can you tell us where can you see this type of shapes in everyday life? This parabolic one. In everyday life?
A bridge.
Yes, a bridge. Very good one. Yes. Anything else?
The McDonald's sign.
Oh, yes. McDonald's sign is a good one. Okay. Anything else? That's there are a couple of things that they are going to be interested in. Okay, it's used, really in industry for making glasses, and this is it. Okay, the glasses are going to be, mine is not almost. Okay, the parabolic one. Okay, these are going to be the shape that we're going to use, and it's used in the design of okay, various, for the cars or those lights, those are going to be parabolic, and the reason is that, and the satellite dishes are all parabolic, because there is a condition that we have for the parabola. You see, this is going to be the one. You know that there is another definition of a parabola. You have a focal point, you call it the focus. Okay, this is the one. And there's going to be a line outside. So the definition of the parabola is like the circle. It's a collection of points that's going to be equal distance from, this line and this point inside. This point is going to be called the focus or the focal point. Okay, so for the satellite dishes, this is the property that they use. These are going to, the waves are coming. Okay, all the waves are coming. So it's going to be a reflection. All of them are going to be at this point. And then this is the reason that you're going to see the image on your TV set, if you like. And the way they send it is going to be just the other way around. This phenomena is used in designing some like stadium, concert halls. When you get a concert hall, this is going to be where they play, because they want to have a good reflection of the sound, if you like. So it's used all over the places, and the good place is in Library of Congress. There is a place they call it Whispering Hall, and that's the same shape on the top. So if you stay here and whisper, if you like, somebody close to you can hear it. And the reason is this reflection of the light. So in physics, and they like it, and many properties of this one. From mathematical point of view also, it's very classic result, and it's going to be quite a lot to talk about it. Okay, and so this max and the mean is used in business. I'll give you one problem later. I want to make sure that I'll get something for the quiz. but otherwise we are going to check it after the maximum revenue, minimum cost. These are two applications that probably you have seen it in algebra, but we give you one nice one that we usually use in calculus, especially in calculus for business. So give it some idea that you'll be ready if you want to take that course. Okay, so let me just bring that. Okay, I posted a practice quiz, I think, in the take-home maybe for you. I remember. So this must be practice quiz number 2. Let's see if I can. Okay, this is the one that I post. I share it so you can see it. Then I will need to have it for myself. So this is going to be one. Can you see it? That's a practice quiz number 2 that I'm going to go over it. So we need the piecewise defined function. Okay, evaluation of the piecewise defined and sketching the graph of the piecewise defined. That's the 2 questions. Okay, getting the graph and evaluation of a piecewise defined function. Then composition of 2 functions. We are interested in, really easy one. The inverse function, remember, easy to find the inverse function. Then a couple of questions on these quadratic function that we talk about it. Okay, so I wanted to put something from those transformation of graphs, but we may not get time. So this is it. So a couple of questions on the quadratic function, 2 types, this classic and the other one. Okay, so it's not difficult, but we want to make sure that give you the quiz on the deadline. So let's go over it. So I cannot share it all the time because I'm worried about I may lose the other camera. So the numbers are going to be the one that are posted. Okay, number 1, 2, 3. I go over all of them for you. Okay, so let's go back and continue getting these numbers. So we give a question, the 6 question on the quiz as usual, and then we give a short lecture, of course, after that. So getting back to that, checking these problems, should you have no difficulty. So this is going to be practice. Okay, practice quiz number 2. Okay, practice quiz number 2. The first one is we want to make sure that you understand how we're going to work with the piecewise defined function. So we give you one and we ask you to evaluate it for us. So this is the function f of x is equal to what? Is equal to the x squared plus 3 when x is less than 2. Okay, it's a 7 when x is between 2 and 4. Okay, between 2 and 4, and it's a 2x minus 1, 2x minus 1 when x is greater than 4. Okay, you know that. We partition the domain of the function. So you better partition it for yourself to just make sure you understand it. So this is your number line. Okay, this is a number line. So what you did, you partition it at 2 points. X is less than 2, this is 2, and this is 4. So you may have 2 partitions or 3. In this case, we have 3. 1, 2, 3. Okay, so if you are going to be in this region, the value of your function, we call it y, is x squared plus 3. If you are going in between, the value of your function is always 7. If you are in this portion, the value is 2x minus 1. Okay? So you have 3 formulas, okay? 3 brackets for your information. So the numbers that they ask you, just put them over here. They ask for the f of 0, f of 3, and 5. Put these numbers. You see 0 is here. Okay, these are the given numbers. So you have the 0, and you have the 3. 3 is here. Okay, this is the numbers that they ask. 3 and 5. and the 5 is here. We may give you more numbers, okay? So these are going to be the one. So these are input, and this is the output. Input, output, input, output. So make sure you can use only one of them, you know that. One formula. So if you want to find the f of 0, you are going to be in the first bracket because the 0 is less than 2. So this is your formula. Would be 0 plus 3, which is equal to 3. So f of 0 equal to 3. Okay, so this is the first one.
Postal service.
That's it, very good, yes, excellent, postal service. Okay, so the second one is f of 3. You are in the second bracket, which is always 7. It's always 7, okay? So this is going to be the one. And f of 5, you are in the third bracket. So it's going to be 2 times 5 minus 1. 10 minus 1 would be 9. So f of 5 equal to the 9, and then you are done. Okay, so we may give you, a couple of more, or we may give you 2 functions as one question. Just make sure you understand it. Okay, any question? So it's very important in calculus, really. I'm just giving the test 1 in calculus. Some of them, they missed it over there. Okay, especially I asked them to graph the function. Most of them, they missed it. So that's why we want to make sure that you know it. In case you come to that course, then you are ready for it. Okay, any question? So we have a number of them in your lecture notes. Just check, be ready for it. 1, evaluation of the piecewise defined function. That's number 1. Any question? Number 2, easy question on the composition of 2 functions. We work quite a lot, so we would like you to operate with this function. Okay, again, nice, we use the definition of a function and then you'll be done. So the first function is f of x equal to the x cubed minus 9x plus 1. That's your first function. And the second function is g of x equal to 2x plus 5. Okay, 2 functions, 2 different actions. We want to compose them together, and we ask usually one general value and one the local one. We ask for the FOG at a -2. Okay, and we ask for the GOF. Okay, GOF at x. Sometimes we have to find it numerically at one number, and sometimes we have to find it in general. Okay, you know that composition function is 2 action. The first action is G, we call it the inside action. Okay, and this second action is F, which is going to be the outside. So write the formula nicely, substitute to get your result. Okay, are you ready? Solution, bring the first one. You see, FOG at -2. The definition first. Okay, so the definition is f of g of -2. So g of -2 must happen first. When it's a number, you stop and you go and you bring it. What is g of -2? Okay, stop, find the g of -2. Go to the g function, substitute. You see, this is the g function. You replace the x by -2, so that gives you 2 times -2. Okay, plus 5. 2 times -2 would be -4. -4 and 5 would be 1. So g of -2 is 1. Now you continue. Okay, so it's equal to f of 1. Okay, f of 1. Now we go to the f function and define the f function, replace the x by 1. So that gives you 1 minus 9 plus 1. You simplify it, so that's going to be -7. Okay, so FOG at -2, okay, is equal to the -7, and you're done. Any question? So 2 steps, make sure that you follow the proper steps. So G first, inside function. G of -2 first. So go to the G function, find it. G of -2 would be 1. Come back, f of 1. Some people, they make a mistake. They want to find the g or f of x first, then substitute. Sometimes it's a hard job, because if you put that one, then you have to find 2x plus 5 to the third. Okay, so there is a reason that they give you the numbers. So just stay with the numbers. Okay, any question? 2 steps, one by one. This is f of g. Now we want to find the g or f of x. Okay, same thing. Are you done? So we are going to have the same thing, and that's going to be a g or f. And the definition first. G or f of x this time. It's x, it's not the number, so we stay with the x. The definition first. G of f of x. Okay, bring f of x. F of x is, okay, f of x is x cubed minus 9x plus 1 plus 1. You see? Previously, it was a number, you drop it into the g. Now it's a box. Okay, you may think about it as a box. So this box is going to be input of the g. What is g? G is 2 times the box plus 5. G of 2x plus 5 means g of the box is 2 times the box, okay, plus 5. So what is in the box? X cubed minus 9x plus 1. So this is going to be, you see, this is going to be 2, the box. This is the box. X cubed minus 9x plus 1. Okay, plus 5. Plus 5. Okay, whatever you have, you drop it into the g function. You have to simplify it, you're not done. So this is going to be 2x cubed minus 18x plus 2 plus 5. Okay, 2 and 5 would be 7. So the g or f at x is equal to, okay, is equal to the 2x cubed minus 18x plus 7. So that gives you the final answer. Okay, a composition of two functions from two different directions. Okay, you know that this is not going to be the same all the time, and we just wanted to evaluate it for us. It's going to be used in future. Okay, any question? So this is a composition question. We have one section on this one. Okay, that's number 2. Number 3, easy function. We want to find the inverse of these functions. Inverse, we talk about it, we switch x and the y. We try to see if we get the new functions. So that is number 3. Number 3, find the inverse of each function. Find the inverse. Okay, inverse of each function. Okay, there are 2 types. The first one is f of x equal to 2x plus 5. Remember, inverse means if you switch x and the y, are you going to get a function or not? That was the idea. So the method that I suggest is, this is y is a function of x. You want to change it into the x to be a function of y. So call this one y, solve for x. That's it. If you can solve it, you got it. If you cannot, you won't have the inverse. Okay, easy question, solution. You are going to let y to be equal to the 2x plus 5 and solve possibly for x. Solve for x. You get the inverse function. It's the other way around. That's easy to solve because you subtract the 5. Okay, so this is it. That gives you y minus 5 equal to the 2x. Okay, or 2x equal to the y minus 5. Divide by 2, so x would be equal to y minus 5 over 2. That is your inverse function. So the way we write it down, remember, the notation is f inverse of y is equal to y minus 5 over 2. Even that would be enough. But if you would like to write it as a new function, you can change it to the x. That's optional. In your book, they ask for the f inverse of x, then you change it to the x. F inverse of x equal to the x minus 5 over 2. I accept this one even as the inverse function. Okay, I explained the method of your book the other day. The method of your book, they switch this one at the beginning. They write x equal to the 2y plus 5. They solve for y. Okay, but this is a natural one. You have to find the x. To find the x, this is your inverse function. Okay, but if you like to call it x, it doesn't matter. Call it t. Call it z. This is just a function. Okay, any question? That's the case 1. Okay, the case 1, linear function. What is going to be case 2? Okay, the case 2 is this rational function. Okay, f of x is equal to, okay, is equal to the 3x plus 1 over x plus 2. You noted that the x is not equal to negative 2 because of the domain. You know that the domain of this function. And so again, you call it y, so for x, okay, solution, you let y equal to 3x plus 1 over x plus 2 and solve for x if it is possible, because you want to switch it, the inverse function. Y is a function of x. The question is x also a function of y? So I should be able to check it. We switch the input of the output. This is the idea. Okay, so we have to cross multiply, remember? Cross multiply. It's going to be y times x plus 2. Okay, it's going to be y times x plus 2 is equal to 3x plus 1. You have to distribute it. Okay, so it's going to be x, y plus 2y, and this is going to be 3x plus 1. Go on. You remember, you want to find the x. So you have to put the x's together. So it's going to be xy minus 3x equal to 1 minus 2y. Factor out the x. Factor out the x is going to be y minus 3 is equal to the 1 minus 2y. You want to solve for x. You got to be careful. You need a condition here. You see, you do it. You divide by y minus 3. But quickly, you write that with the condition that the y is not equal to 3. If you don't have this condition, you can't do it, remember. If you don't write this condition, you are not done, remember. Okay, so you have to impose this condition that the y cannot be equal to 3. Okay, then you have it. Then you can say that the f inverse of y is 1 minus 2y over y minus 3. Or if you like the x, we can change it to the x. We don't mind. Okay, so that's the inverse function. It's easy, but we need it. We need it in future. In one place, we want you to make sure you understand that. Okay, y is a function of x. The question is x also a function of y? Maybe. We have to try it. We have to try to see if it is possible. If you want to be precise, I put another part for you. Just make sure you remember it. You see this part, remember? Just give you an idea that f of x equal to the x squared, okay? Just to make sure you get all the possibilities. Okay, Previous page, what do you want? Previous page. That is the previous page. Okay, done. So we go to this one. Okay, so this is a situation that we have. So in this case, you see everything was nice. And for the other one, we impose the condition. But this function is a special one. F of x equal to the, remember, x squared. So we check this one to see. So the solution is going to be, we again let y equal to the x squared and try solve for x and solve for x possibly. You know that to solve for x, we have to take the square root, radical x squared, and you know the difficulty. This is a radical y, but this is the absolute value of x. That's it. You cannot find the x. Because when it's absolute value of x, remember, you drop the absolute value, but you are going to have what? So you get the x equal to the positive negative radical y. You see? In order to get the function, remember, you need only one solution. You get two solutions over here. You see, they share the first component, if you like. So this means this is not a function. You cannot say that f inverse of y is equal to the positive negative radical y. So at that case, you know, it's not possible. It's not possible, so the inverse, okay, there is no inverse. There is no inverse for f. Unless you restrict it. Unless you impose that x is positive. If x is positive, yes. If x is positive, we drop the absolute value. X would be radical y. But since they didn't give you any condition, so this means it's not possible. So if you can solve for x, okay, and we get a unique solution, yes, we have an inverse function. So in this case, we don't have a unique solution. So this means the inverse, okay, function does not exist. The inverse is not a function. That's the idea. Okay, so that's the inverse function. Any question? That's the number 3. What's the number 4? That's it. Sketch the graph of the piecewise defined function. Very important to make sure you get this one right and for future applications. I'll give you the instruction. You have to follow that one. Okay, so what was the instruction? Number 4, we want to scratch the graph, sketch the graph of this piecewise defined function. Remember, the piecewise is two pieces or 3 pieces. If you can connect them together, it's one case. We say it's a continuous. If they are going to be separated pieces, it's going to be discontinuous. So you have to find out which one is it. So let's take the first one. F of x is equal to, it's x plus 2 with the restriction that x is less than -1. Okay, and it's x minus 2 with the restriction that x is greater than 1. Then there is the misprint. This must be -1. Does that make sense? Okay, less than -1 and greater than -1. You say it's partition and -1. So you graph both parts. The first one with the restriction and the next one with the restriction over here. And then maybe you may be able to connect them together or they may be separated. Okay, so let's check. We graph the first part first. So I'm going to go to the next page so I have enough space today. Okay, so this is, I think I put the negative here bigger than equal to the 0 to make it better. So I changed that one is all out. There's a misprint here. Okay, so what we're going to do with this format, we graph each part separately We graph the first part. So the first part is y equal to the x plus 2 with the condition that the x is less than negative 1. I talk about it, when I was giving you the instruction. You see, this is x, this is y. You must start with the negative 1. Okay, because this is up to the negative 1, up to the negative 1. So we start with the negative 1. Don't worry about the equality sign. We estimate it only. Okay, we estimate it. If you don't pick this number, your graph is out. You are going to have a leftover. Okay, up to the negative 1. If you put the negative 1, suppose it is in. So that gives negative 1 plus 2, which is going to be 1. Okay, something less than negative 2. Okay, that gives us a negative 2 plus 2, which is 0. Now we are going to sort it out here. You see, we check this point first, negative 1, 1. You see, this is a negative 1, 1. Negative 1, 1. But since we just estimated, there is no equality sign here. So what we're going to do is, we're going to make a hole. This means up to the negative 1, but not the negative 1. Okay, so we estimate it. So it doesn't matter. Pick this number first, estimate it, then you take it out. Because other than the negative 1, everything else is covered. Everything else is covered, okay? So don't miss it. The next point is the negative 2 and 0. This is a negative 2 and 0. But remember, your function goes to the left. Going to the left only. So this is a negative 2, and this is going to be the graph of your function. Any question? So some people, they don't pick the negative 1. They say the negative 1 is not covered, but they pick a negative 2. So their function would comes from here, you see? Then this portion, you see, there is nothing. So your graph is not complete. Because less than negative 1 doesn't mean that from negative 2. Less than negative 1, there are many numbers that's going to be very close to the negative 1. So pick the negative 1, then take it out. That's the best format. Other than this, you are out. Your graph is not complete. Okay, make sure you do it. So that's the first part. Any question? The second part, y equal to the x minus 2. Okay, and the x as I change it. Okay, then equal to negative 1. Again, you start with this negative 1 again in both cases. That's x, y. It's a negative 1. So that you have a negative 1 minus 2, which is a negative 3 this time. Okay, now less than something bigger than negative 1. To the right, like 0. So that give a negative 2. Okay, so that gives you a negative 2. Go back, identify it. You see negative 1 and 3. This is a negative 1. Negative 3. Negative 3. 1, 2, negative 3. So you are going to be starting from here. So that's your negative 3. Then you check to see if you have it. You see there is the equality sign. Since equality sign, you make it solid. Okay, you see this is empty, this is solid. Of course, remember you cannot have both of them to be solid because of the vertical line test. That's why you have to start with a negative 1. Okay, something else, it's a 0 and negative 2. So this is 0 and negative 2. You connect, remember this time you go to the right. You go to the right. This is going to be the graph of your function. It's nicely done. You see less than negative 1 you are here. Greater than negative 1 you are here. And there is no connection. You see nothing. Some people, they make a mistake. They have their graph here. You can't have it because you know that in that case, the vertical line would intersect your graph. So that's why you have to keep the boundary, if you like. That boundary is negative 1. If you don't sort it out at the negative 1, it's going to be a mix on it. Okay, you're going to miss it. So make sure that start with that. Negative 1, doesn't matter. You take it out if it's not covered by the graph. Okay, any question? So that's going to be the case that you cannot connect them together. In calculus, we say this is discontinuous. It's two portion, okay, this partition point. You are not able to connect them together. So there are various cases that we arrive at this phenomena, if you like. Okay, that's case one. We give you two cases, or there are two cases. Let's check part B. Part B should be the one, I think, the one that you should be able to connect them together. So this is your function, f of x equal to, the function is a negative 1 minus x. Okay, for x less than 2. And you have a 5 minus x, 5 minus x when x is greater than equal to 2. Okay, this is the one. So your graph partition at 2. So get the two portions of the graph. Okay, it's a negative 1 minus x. This is it. So we graph the first part, y equal to the negative 1 minus x with the partition of less than 2. Again, to make sure that we are not going to go over, so we establish the 2 again. You substitute negative 1 minus 2 would be a negative 3. Okay, that's the first part. Something less than 2, like 1. So negative 1 minus 1 would be a negative 2. Question. So identify this part. Okay, get the graph of this part to see what's going on. So this is the case. So 2 and negative 3, identify 2 and negative 3. X equal to 2. We have a negative 3, 1, 2, 3. So that's a negative 3, and this is going to be 2. You check to see if you are going to accept this point. No. There is no equality sign, so we make a hole here. Okay, and the next point is going to be 1 and negative 2. This is 1 and the negative 2. This is 1 and negative 2. You connect, and you know that you go to the right. So this is going to be your graph. Okay, that is going to be the first part. Okay, question. Get the second part. That was 2, negative 3, 1, negative 1. We get the second part. Second part, y is 5 minus x. The partition is again 2. So start with the partition point all the time. You put x equal to 2. So that gives 5 minus 2, which is 3. Okay, which is going to be 3. And something up like 3. So it's going to be 5 minus 3, which is 2. Okay, so 2 and 3, this is not going to be again 2, 3, 1, 2, 3. So this is going to be the point. You get the equality sign, so you make it solid. At 3 and 2, this is going to be 3 and 2. So you connect, you go to the right. This is going to be your graph again. I wanted to be just put them together. We didn't get it. Okay. So this is going to be the second case. I do the part C. Even in part C, you want 18. That is, no, it's going to be all the same. Okay, so if I get time, I'll come back and do that one for you too. I give you a 5 minutes break, okay? So we come back and we do the quadratic one, the one that we talk about it tonight. Okay? Okay, we have a couple of problems on the quadratic function that we talk about it tonight. Okay, so the first part is quite different from what we did. Okay, you have a couple of problems in your book. Remember, I give you for the quadratic function, so we have two different categories. Okay, this is what we did. The equation can be given in this form: y equal to the a times x minus h squared plus k. If this is given to in this form, so the vertex is going to be h and k, and then the rest of the argument is going to be the same. You see the maximum, the minimum, the graph. So this is one version. The other version is if this is going to be classic, it's going to be ax squared plus bx plus c. Okay, so the vertex would be this one, negative b over 2a, comma, f of negative b over 2a. So you should expect these two, because you have to find the vertex, okay, in both cases. So this is the vertex for the, okay, vertex, and this is the vertex. So whatever you want to do with these problems, you have to find this one. Okay, so just make a note of this formula, especially don't miss this one. Whatever number is here is opposite like the circle, but this is exactly the same thing. Okay, now one problem that you have to use the first part is this problem number 5, and you have a couple of them in your book. That's why I put this one so that you know it. So what is going to be number 5? It's like the problem that we did for the circle. Remember, some information were given and we were able to find the equation of a circle. This is the same thing. So what they want you to find a quadratic. Okay, determine. I write it down so that you know it. Determine a quadratic function. Quadratic function. Okay, a quadratic function with vertex. Okay, with the vertex of a negative 3, comma 2, and passing through a point, and containing or passing through, okay, passing through this point. The point is 1 and 6, like a problem of a circle. To do this problem, you have to use this version. You see, that's the one. You see, this is the equation of a quadratic function. This is h, this is k, and this is a. So you need to know all these three quantities, a, h, k. In this problem, the vertex is already given to you. So you have the h and the k. So you have to find the a, like the one that we did for the second, but we have a point. This is x, this is y. You substitute and you get it. Okay, so for this special problem, this is what you are going to do. Solution. You remind yourself that this is the formula. A times x minus h squared plus k. Then you go back and you check. Make sure you get these numbers correct. Vertex is h and k. Point is x and y. Okay, so what you can do is you can get these numbers done. Okay, to get the, or you can get the h and the k first, you know, it depends. So your function is, so far a is missing. It's going to be x minus h, so we get a positive 3, all squared plus k, which is 2. You see, substitute for the h and the k. A is missing. So now you bring that x and the y that you have, 1 and 6. So if you substitute, it's going to be 6 equal to a is the missing one, x plus 3, which is going to be 1 plus 3, all squared. Okay, all squared plus 2. You get the a. So this is 6. 1 and 3 would be 4. 4 squared would be 16. It's a 16a plus 2. Okay, so it's going to be what? 6 minus 2 equal to the 16a. Okay, 16a, so it's going to be 4 equal to the 16a. So a would be 4 over 16. A is going to be a quarter. Okay, now you go back and substitute and you're done. So y is equal to a quarter times x plus 3 all squared plus 2. This is the equation of a parabola or the quadratic. You don't have to simplify it. Some people, they square it, simplify. No, that's the end of the problem. Okay, so don't miss it. You may be able to do all the problems just using those classic formula that we talk about it, but not this one. You need this, call it conical form or just a standard form. Okay, so y equal to the a plus x minus h squared plus k. You have the h and the k because, the vertex is given to you. So you need to find the a. So to find the a, you need an equation. So you have the x and the y with the given point. Then you substitute and you solve for a, and then you're done. Okay, so that's number 5, which is different from the others. But the rest are the type that we did together. So that's going to be 5. We give you just a couple of them, but these are all the possibilities. Okay, so to sketch the graph as we did, you may be given 2 possibilities. This is it. Number 6, I put all the possibilities together as A, B, C, but we just go over a couple of them. Okay, they're all the same. So number 6, they ask you to identify the vertex and axis of symmetry and sketch the graph. So I just simply say sketch the graph. There are 2 cases, so let's try to quick one to finish it. Okay, case 1 is classic. F of x is equal to the negative 2x squared minus 4x plus 3. Okay, you have to use the first formula. You have to find the vertex, axis of symmetry. So you identify the a is a negative 2, and the b is a negative 4. Okay, a negative 2, b is a negative 4. Okay, so we get the x is equal to the negative b over 2a for the vertex. Is going to be negative b is a negative 4, 2a, 2 times a negative 2. Okay, so this is going to be negative, it's a negative 4, and that's going to be a negative 4. 3 negatives would be negative, and this is going to be a negative 1. So x is a negative 1. You drop it into the function, so that gives f of negative 1, which is negative 2 times negative 1 squared minus 4 times negative 1 plus 3. Okay, negative 1 squared would be 1, so that gives a negative 2. Okay, plus 4 plus 3. That's going to be 7, that give you 5. So f of negative 1 equal to the 5, so the vertex is going to be negative 1 and 5. See, that's this classic formula that we have. Okay, and the axis of symmetry is going to be a negative 1. So that's going to be axis of symmetry. Now we want to graph it. We preview first. Your A is a negative 2. Okay, A is a negative 2. So the negative means done. This is the graph. So we are going to confirm it. This is it. Get the vertex is a negative 1 and 5. Negative 1, this is a negative 1, 5, 1, 2, 3, 4, 5. Okay, this is going to be the vertex. Graph is going to be curving down. So that's a mirror. You need help. We need one more point. Help. I put the x equal to the 0 to get help. If I put x equal to the 0 into the function, so the y would be 3. So that gives me 3. So identify this point as 0 and 3, and you know it's going to be curving down. So that's going to be 1, 2, 3. This is one point. You connect, and symmetric format to get the other part. So that gives me the graph of the function. Okay, they didn't ask, but if they do, this is 5. So the maximum is 5. Okay, the max value of the function is 5. What's the range of this function? Range? Any suggestion?
Negative infinity to 5.
That's it. Negative infinity to the 5. Very good. Because when is the maximum, the end is given. The end is the 5, so we start from negative infinity. If the minimum is given to, the beginning is given. So the beginning up. Okay, so that's going to be case 1. And this is going to be classic case. And we may give you that, you know, the other standard one. Okay, check that one too. Any question? Are you done? So the part B is the other format, and the other are going to be all the same.
Remember.
Yes, question? Okay, the part B is only 2 types. So what's going to be the part B? The function is f of x is equal to the 3 times x plus 1 squared, okay, minus 2. That's the other format. So just stay with whatever you have. Some people try to simplify it. You don't need to simplify. Okay, so we get this one right away. So you compare it with the second case. So that's going to be the y equal to the 3 times x plus 1 all squared minus 2. Okay, so in this case, you know that the vertex is going to be opposite sign, a negative 1 comma negative 2, and the a of 3. Okay, so that's easy case. Everything is already given to you. So there you are. Excess of symmetry is a negative 1. So you want to graph it. You estimate it first. Okay, a is equal to 3. 3 is positive number. Positive means up. So the graph would open upward. So get the graph. This is it. Okay, we get the point, negative 1 and negative 2. This is going to be negative 1, negative 2. So this is going to be the vertex. Excess of symmetry, this is going to be the mirror. Okay, the mirror. So we need help. We know it's going to be going up. So the help, just get 1 point. You can pick any point you like, of course. I picked the 0. If you put the 0 here, so that gives you 3 times 1 squared minus 2, which is equal to 1. Because 1 squared would be 1. Okay, but now it's going to be curving up, and we have a 0 and 1. This is 0 and 1. And this is your vertex, okay? So we get a first portion. This is going to be the first one. And symmetric property to get the second part. Okay, that's going to be 1. Some people find they find intercepts even in your book, but you don't need it because we just use symmetric property, and we can take care of it. Okay, so that's going to be curving up, and this is the bottom. The bottom is going to be the minimum, which is going to be -2. Okay, so the bonus is that the minimum value of the function, okay, the minimum value of the function is going to be -2. So the range of the function, okay, the range of f, you know that you start from the minimum and you go up forever. So that gives you the graph of the function. Okay, any question? It's not a big deal. The other one, I just put some to find the domain and the range of the function for you to practice. So I give you one of them, number 7, especially 7 part B, which is going to be that easy part. Okay, or some with the fractions. Let's see if we can do both of them. As you can see, all of them are, you see, the only thing that you do for us, you are going to find the vertex and axis of symmetry, and then check to see what they want you. They want you the domain, the range, the maximum, minimum. So it's a number 7. They ask for the domain and the range. Okay, find the domain and the range. Domain. Okay, and the range. It's the same thing, but you don't have to graph it. That's the ideal. Okay, we have one classic, one standard. Okay, both formula are going to be used. So the classic one is this one, part 1. It's they give you always kind of fractional one. Like this one, it's a -2/3 because you don't want to graph it. It's x squared plus 3x minus 4/3. You see, the domain is clear. Don't miss the domain. Domain is R. To find the range, you need to find the max or the minimum. Okay, to find out whether you go up or down. So you estimate it first. -2/3 is negative. Negative means done. So you're going to have a maximum. So you find the vertex. Okay, the y value of the vertex that give you the largest value, the maximum. Okay, so you go for it. And this is your A, and the B is equal to the 3. So we have to find the x equal to the -b over 2a. You've got to be patient for this one. With some fraction, but it's not a big deal. It's a negative. Your b is 3 on the top, and the 2a down the bottom is going to be 2 times, okay, the a of a -2/3. Okay, this is going to be the case. So what's this one? This is going to be -4/3. Okay, then it's the negative here. So it's equal to -3, and this is going to be the 4/3. You have to switch it and the multiply it reciprocal. So it's going to be 3 times 3 would be 9. Okay, there's a negative sign here. Double negative would be positive. So we don't have to write the positive. It's going to be 3 times 3/4, which is a 9/4. See, it's going to be fraction. Okay, it's a kind of division of 2 fractions. And we write the first one, we multiply it by the reciprocal of the bottom one. So that's going to be your x. You drop into the function to get your maximum. So what's going to be f of 9/4? Okay, f of 9/4 is going to be -2/3 times a 9/4 squared. Okay, plus 3x, 3 times a 9/4, and the minus 4/3. Okay, you should simplify it a little bit. That give you the maximum. So 9 squared would be 81. It's one of the problem in your book. 2/3. This is going to be 81 over 16. And this is going to be 27 over 4 minus 4/3. Okay, you simplify. This would give you 27. And this would give you 8. So f of 9/4 is equal to, okay, this is going to be a negative 27 over 8 here, 27 over 4, and finally negative 4/3. Okay, better get the 4/3. Yes, the 4/3. You can simplify it, to get that in that range. The common denominator would be what? It would be 24. Okay, you need to simplify it. So it's going to be negative. This is going to be 24. You multiply this one by 3, which is 81. And this is going to be 24. You have to multiply the top by 6. Okay, 42. Okay, 6 times 7, 42, 12. 16. And this is going to be 24 and the 32. Okay, this is the one. It can be simplified to get the final number. What is that? You have the 24 here. Okay, this is going to be 162 minus, if you add these two together, and that gives you 3, and this is going to be 111. Okay, so finally this is going to be 24, and the top is going to be 949. Okay, that's the one. I think so. This is the maximum value of the function, and then you can find the range. Okay, so I put it over here. The maximum value of the function, okay, is equal to 49 over 24. So the range is equal to negative infinity up to the 49 over 24. Okay, it's going to be a nice one, but it's not the problem of your book. I just wanted to say that, it's possible. If you want to use your calculator, put all the decimals, and that would be done quickly. But this is going to be the case, but it's going to be a nice one for the test. Okay, that's a part 1. If it's classic, the part 2 is easy because that's going to be second format. In the second format, everything is nicely given to you. You just use the formula to get it. Are you done with this one? So I write the solution of the second part, so we get all the 2 possibilities that we need. Okay, as you can see, all of them are the same. We can check this one even in, at the same time. We don't have to give you 2 separate problems, but we are ready for it. Part B is the second format, which is match, easier. Okay, same question with this function. 4 times x minus 3. Let me give you this part. That's the one. You see, in this format, everything is easy because remember, A is 4, and the vertex is opposite side, 3 and 1. That's the vertex. So the domain is all real numbers. To get the range, you have to check to see what do you have. Do you have a maximum or do you have a minimum? So A equal to 4 is positive. Positive means up, so we have a minimum. Minimum of the function is clear. Minimum is the y coordinate of the vertex, remember? F of negative b over 2a, which is 1. So that's a minimum. So the range is going to be minimum up. That's the one. So if it's going to be second format, it's much easier, because you don't have to evaluate it, but you have to find out which one is it. Is it the maximum or the minimum? And the value. I've given this one on the test. Most of the people, they pick the 3 here to write. No, 3 is not. Remember, the mean or the max is the value of the function, the second part, not the first part. It's the second part. That's it. So we are ready for it. Practice quiz. Okay, that was practice quiz number 2. We use 6 questions from the topics of this review that we're going to have. Okay, any question? So bring those assignment for us. Okay, just check. I think I give you by the Friday. I'm not sure about that, but I give you just to read the announcement regarding the numbers. So you get 10 points for your assignment. Make sure you do it. Okay, any question? So have a good night and take